Hello everyone, today we have topic recurrent neural networks part 2. In part 1 we have already seen into the previous lecture. In the first part of the recurrent neural network we have discussed feed forward neural network and recurrent neural network basics. Feed forward neural network cannot be used when predicting a word in a sentence as it will have no absolute relation with the previous set of the words. So this is the biggest drawback we have already discussed in the previous lecture. If I talk about the recurrent neural network, so recurrent neural networks are a type of artificial neural network designed to recognize pattern in sequence of data such as text, genomes, handwriting, spoken words, sentences, and various numerical time series data, etc. and so on. So from the sensor, stock market, and government agencies. So for a better clarity, we have seen already this concept through an example. Today our topic will be started from the long short-term memory network. Long short-term memory network is usually just known as the LSTMs. So these are the special kind of the recurrent neural network which are capable of learning long-term dependency. So what are the long-term dependencies? Many times only recent data is needed in a model to perform operations, but there might be requirement from a data which are obtained in the past. So now we have long short-term memory topic. Long short-term memory consists of following memory block format. So each memory cell has to store some state. If I talk about the input gate, so it is required to control what to learn, and forget gate it means the controls what to forget, and the purpose of output gate to controls the amount of content to modify. Consider a language model trying to predict the next word based on the previous ones. If we are trying to predict the last word in the sentence, say, the clouds are in the sky, the content or the context here was pretty simple, and the last word ends up being sky all the times. In such cases, the gap between the past information and the current requirement can be bridged really easily by using recurrent neural network, that is RNN. So problem like vanishing and exploding gradient do not exist, and this makes LSTM network handle long-term dependencies easily. LSTM have chain-like neural network layer. In a standard recurrent neural network, the repeating modules consist of one single function as shown in the diagram, as you can see over the slide. So as shown by the diagram, there is a 10h function present in the layer. This function is a sketching function. So what is a sketching function? It is a function which is basically used in the range of -1 to +1 and to manipulate the previous values based on the inputs. As denoted from the image, each of the function in the layers has their own structure. When it comes to LSTM networks, the cell state is the horizontal line in the figure, and it acts as a conveyor belt or carrying the certain data linearly across the data channel. So for this understanding all the concepts, let us consider a step-by-step approach to understand LSTM network better. Now let us consider a step-by-step approach to understand LSTM networks better. So this is the point where we need to start all the steps for understanding LSTM networks in brief. This is a simple diagram of the LSTM memory block where CT minus 1 basically is what and ST minus 1 is basically what, ST minus 1 is basically what. These are the three questions we should have in our mind. CT minus 1 is means the cell state information which is coming from the timestamp T minus 1. Same respectively, ST minus 1 belongs to the some information which is coming from the hidden layer and timestamp based on the T minus 1, while xt is the input which is given by the timestamp t, and yt means the some output we are producing on the timestamp t, while same case we have the ct and st as well. There are some information also mentioned into the diagram, that is it, ft, C bar T, C T, O T. So there is some information. IT means the input which is based on the some timestamp T. FT means the some for some function which is generated by the timestamp T, but F stands for the forget. So all the information which is coming from the in the form of the gate nature. And the C bar T means that there's some information which is belong to the candidate layer. Talk about the candidate layer based on the some timestamp T. Same CT means there are convenient belt, so this is also followed by the or known as the cell state. And while OT means the output on timestamp based on the T. The first step in the LSTM is to identify that information which is not required and will be thrown away from the cell state. This decision is made by the sigmoid layer called as a forget gate layer. So as you can see over the diagram, the HT-1, XT and FT. So HT-1 is some information which is coming from the hidden layer, the previous hidden layer, while XT is the current input and based on timestamp T, and FT is the forget layer function which is just having some information on the timestamp T. So FT can be calculated by which is equal to sigmoid of the WF HT-1 XT plus VF, where WF is equal to wait, HT-1 is the output from the previous timestamp, XT is means the new input, and VF means the bias. So the highlighted layers in the above is the sigmoid layer which is previously mentioned. The calculation is done by considering the new input and the previous timestamp, which eventually leads to the output of a number between the 0 and 1 for each number is that in the cell state. So a typically binary 1 represents the keep the cell state, while 0 represent the threshold or just thrown away such information. So there is some information we have already seen to the step number 1, that is known as the forget gate here. If the information is not necessary, then it's directly thrown away and represented by the FT. Consider gender classification. It is really important to consider the latest and correct gender when the network is being used. So this could be understood by the simple example, but now we have the step number 2, which is the input and candidate gate. So the next step is to decide the new information we are going to store in the cell state. This whole process comprises the following steps, and there are two steps. One is a sigmoid layer called the input gate layer, which decide values will be updated. If I talk about another part, then the 10H layer creates a vector of the new candidate values that could be added to the state. And there is some information which is mentioned over the diagram, that is IT and C bar T. So IT is a input to some input information which is based on some timestamp, and C bar T means that is candidate information of the candidate value of the based on the timestamp T. So the input from the previous timestamp and the new inputs are passed through a sigmoid function which are gives the value, that is IT, and this value is multiplied by the CT and then added to the cell state. So this is a step which is required to into the coming content, that is important part. So I is equal to sigmoid WI HT minus 1 XT plus VI. So all the information we are already familiar with all these terms. What is VI, WI, VI, XT minus 1 and XT. And if I talk about the C bar T, in C bar T, the function we are using the 10H function. 10H function why we are using, because the information which is ranging from the minus 1 to 1. So same case we are using and passing some information and using such information to manipulation purpose as a deciding the candidate values. So in these steps, these tools are combined and update the state. The next step is a memory cell. So now we will update the old cell state CT management to the new cell state, that is CT. First, we multiply the old state CT minus 1 by FT, forgetting the things we had decided to leave behind earlier. So this could be happen into the diagram. So into the diagram, you can easily see the all the state, and the equation is generated. CT is equal to FT into CT minus 1 plus IT into C bar T. Then we add IT into C bar T. This is a new candidate values scaled by how much we decided to update the each state value. In the second step, we decided to the make use of the data which is only required at this stage. So in the third step, we actually implemented such thing. So this is a good thing and thus good important steps we have done so far. Now this is a step number 4, which is known as the output and hidden gate layer. So we will run a sigmoid layer which decide what parts of the cell state we are going to output. Then we put the cell state through the 10h function, which is through the ranges from the -1 to +1. Later we multiply it by output of the sigmoid gate so that we only output the parts we decided to. So the values which is represented by the output gate, that is OT is equal to sigmoid under bracket WOHT minus 1 XT plus VO. So everything you know familiar what is WO and VO. VO means vice and WO means the weight. So HT is also understood by the HT is equal to OT into 10H CT. So the calculation in this step pretty much straightforward, which eventually leads to the output. However, the output consists of the only the output they were decided to carry forwarded in the previous steps. So not all the output at once. Summarization of the all the 5 steps can be done in easily manner. So this is just known as the output and hidden gate. So output gate can be understood by the OT values and hidden gate can be understood by the ST values. So now LSTM memory block can be understood by the with the combined nature in the all the layer togetherness. So if we talk about the first step, we found out what we needed to be dropped, and the second step decided of what we knew inputs are added to the network, and the third step was to combine the previously obtained inputs to generate the new cell state. Lastly, we arrived at the output as per the requirement. So all the information which are commonly mentioned to the diagram, what we have done so far, this is the simple steps as you can see over the slide. Here we are using use case in for the long short-term memory network. So the use case we will be considering is to predict the next word in the simple or sample short story. So we can start by filling an LSTM network with correct sequences from the text of the three symbols as input and one labeled symbol. So in the diagram you can see that there are how many symbols we have. There are three symbols. One is a head, second one is A, and third one is general. These input symbols belongs to the as an input part and represent form of the input layer. If I talk about the other part, what is the output would be. So yes, you can see the output into the different manner. But LSTM, what is the purpose of the LSTM cell? So this purpose of the LSTM cell we have already seen. But LSTM cell with the three inputs and one output. So what is the output? Output will be the council output, and it should be matched with the prediction part. If the council will be matched with the prediction council, then we can say okay, this is the correct. Else the output is not correct and the LSTM network is not perfect or not correct to the our desired requirement. So if the data set we have taken for this use case, the LSTM is trained using a sample short story which consists of 12 unique symbols, so comma including commas and periods, and are also considering as unique symbols in this case. So you can just make an any story and solve such kind of problem and find the answer. So it is depend upon the what kind of need you follow. But it is in the training, so we already know that teams can only understand real numbers. So the first requirement is to convert the unique symbols into the unique integer values based on the frequency of occurrences. So doing this, we will create a customized dictionary in that we will make use a letter on a map the value. So such information you will see into the next slide. So as you can see, we have just written a short story starting from long ago and so on so to including all the punctuation marks, the period symbol, and so other thing. Then if you talk about the figure just in this figure, the certain symbols are mapped to be integer as shown. So the network will create a 112 element vector consisting of the probability of occurrences of each these unique integer values. So this is the simple idea about the use case. So we have seen what is the purpose of use case and how we can LSTM do work. So this is a long step. Now, there are some references I have taken to design this slide and this video for the student purpose as well as all the faculty member who can use the LSTM concept. The references are taken from the various websites, so I'm just putting over the three important references, and two are belongs to the paper, research paper, research articles where the student can learn so many things about the learning phrase representation using RNN. And let me clear to all of you once again the most advantage of LSTM to understand how we can machine translate our information, and the machine translation is the biggest advantage of the RNN as well as the LSTM. Thank you all.